Lesson 7 is on the distance on the coordinate plane. So we're going to be dealing with the coordinate plane again and finding the distances between 2 points. And we're going to learn 2 different ways to do that this lesson. Let's take a look at the real-world link that you have to start off this lesson. Okay? It says Evan was biking on a trail. A map of the trail is shown. His brother timed his ride from point A to point B. So he started here, and he rode his bike up this path to point B. Okay, question 1. What do the blue and red lines on the graph represent? So take a few minutes here and look at this picture and write down in your book what the blue lines represent. Okay, so let's see what you had here. The blue lines represent the horizontal and vertical distances between the 2 points. The red line represents the actual distance between the 2 points. If you had that the blue lines represent the legs of a right triangle, I would accept that as well. Okay, but they're talking about the vertical distance and the horizontal distance between the 2 points. Okay, and the red is actually his distance, or if you had the red was his hypotenuse, I would accept that as well. It says, what type of triangle is formed by the lines? Okay. I think that we know that that answer is a right triangle. Okay, that's what we've been talking about. The third question, how can you find the lengths of AC and BC without counting the number of grids? Okay, so how can you find AC right here and BC without counting the boxes? That's what they want to know. There's a couple different ways. Okay, what you can do is you can subtract the x-coordinates. Like if we count, we know that it's 1, 2, 3, 4. Okay, but they want you to come up with another way. If you take the x-coordinates, since we're moving along the x-axis, if you take 7 minus 3, you get 4. Okay, so instead of counting the boxes, since we're on the x-axis, just find the difference between the x-coordinates. And it's the same thing with the y-coordinates. This is the y. We know that it's 1, 2, 3, 4, 5 and a half, but if we're not allowed to count, what you can do is take 9.5 minus 4, and it gives you 5 and a half. Okay. What are the lengths of the 2 blue lines? Well, we just talked about that. Okay, 4 and 5 and a half. Then the last question: write an equation using the Pythagorean theorem. So that you can find the length of AB. So they want you to go ahead and just write the equation. You don't have to solve. But for right now, write an equation so that we can find this hypotenuse, which was his trail when he was biking. So 4 squared plus 5.5 squared, those were our 2 legs, equals c squared. Okay, so kind of the same thing that we've been doing. So let's actually look at an example here. It says find the distance on the coordinate plane. Okay, this is the first way that we're going to talk about finding distances between 2 points. Okay, it says graph the ordered pairs 3 and 0, 7 and negative 5. Then find the distance C between the 2 points. So the first thing you have to do, we have to remember how to plot points. Okay, so here's 3 and 0 right here. Here's 7 and negative 5 right here. They want you to find this distance. Well, again, it's diagonal. It's not vertical or horizontal, so we just can't count the boxes. Okay, so what we have to do is make our right triangle, kind of like what we did with slope. Do you remember when we did rise over run? Okay, it's the same thing. We need to make our triangle here and count our distance. So if this is 5 and this is 4, those are the legs of our triangles. And you can see over here they used the Pythagorean theorem. And they replaced A and B with 4 and 5. Then they solved and they got 6.4. So this length, the distance between 3 and 0 and 7 and negative 5 is about 6.4 units. Okay. So we're doing the same thing, but now we're working with distances. Okay. So let's take a look at your got it problem. Okay. The first thing you need to do is you need to plot 1 and 3, negative 2 and 4 on a coordinate system here, on a coordinate graph. Okay, so here are your 2 points right here. Here's negative 2 and 4, Here's 1 and 3. So what we need to do, we want to find the distance between those 2 points. So we have to go ahead and we have to make our triangle. Okay? So we need to find the lengths of the legs. Well, this length right here, this is one box, right? So this is 1. Right here, 1, 2, 3. This length is 3. So now we know the legs of our right triangle, and we're finding our hypotenuse, which is the distance between the 2 points. So right now, start with the Pythagorean theorem. Go ahead, pause the video right now, and plug in your numbers and solve for the distance. Okay, let's see how you did. When you plug these in, 1 and 3 are your legs. Okay. We square 1 and 3, we get 1 and 9. So 1 plus 9 is 10. Now remember, 10's not your answer. Okay, we want c by itself, not c squared. So we have to take the square root, and we get 3.2. So the distance from this point to this point is 3.2 units. Okay? Now let's take a look at the second way we're going to do it. We're okay with that first way because it's what we've been doing the last 2 lessons. Now we're going to kind of learn a different way. Okay, it's called the distance formula. The distance formula does the same thing as the Pythagorean theorem. Okay, I know that this formula right here looks complicated, but really it's the same thing as the Pythagorean theorem. If you take a look, you have something squared plus something squared, almost like a squared plus b squared. And then at the very end, what you have to do is take the square root of that answer. It's the same process. The formulas are related. Okay, so what we have to do is we have to look at our coordinates. Our x and our x2 and our x1 come from the coordinates. Just like when we did slope. Okay, we had to label x1 and x2 and y2 and y1. Okay, we do it the same way. Let's look at an example problem. Okay, it says on the map each unit represents 45 miles. So this map over here. West Point, New York is located at 1.52, and Annapolis, Maryland is located at -1.5 and -1.5. What is the approximate distance between West Point and Annapolis? Okay, so we're looking to find this distance from Annapolis to West Point. There's 2 methods. The first method we talked about using the Pythagorean theorem. Okay, it says A is 3 and B is 3.5. Again, we did our triangle here. That's how they got these distances. 1 was 3 and 1 was 3.5. Those were the legs of our triangle. They worked out the Pythagorean theorem and they got that the distance was about 4.6. Well, C was 4.6. Okay. Let's see how they used it when they did the distance formula. Okay, what we have to do, let's rewrite those points up here. We have 1.5 and 2, okay, and we have -1.5 and -1.5. Let's go ahead and let's make those values, let's label them. Okay, let's label those. So this is our x, and this is our y, okay, and this is the first point, so we're going to make that x1 and y1. This is our second point, this is an x, this is a y, but since this is our second point, let's make that x2 and y2. Now that we know what each one of them represents, all we have to do is take this formula right here and plug in our values. Okay, so we're going to take x2 minus x1. Well, let's look up here. x2 minus x1. Okay, see how they have -1.5 minus 1.5? Then we do the same thing with our y values. -1.5 minus 2. Now, following order of operations, we do what's in parentheses first. So -1.5 minus 1.5 is a -3. -1.5 minus 2 is a -3.5. Again, following order of operations, our next step is to square them. -3 squared is 9. -3.5 squared is 12.25. Add them together, we get 21.25. And just like in the Pythagorean theorem, our last step is to always find the square root. So the square root of 21.5 is 4.6. You can see that we end up with the same answer, okay? Because they're basically the same formula, okay? Okay, let's take a look at your got it problem. Let's first do it by using the Pythagorean theorem. Okay, so what we need to do is we need to plot these points on the grid here. So 2.5 and 3.5. So 2.5, 1, 2, 2.5, and we're going to go up 3.5. 1, 2, 3, 3.5. So here's our first point, right there. Then let's plot 1.5 and 4.5. So 1.5 is right here. Then we're going to go up 4.5. 1, 2, 3, 4.5. Okay, there are 2 points. So let's go ahead, let's make this a right triangle. Okay. We're finding the distance from this point to this point. So let's figure out what our lengths are. What's this from here to here? This is a value of 1. From here to here is a value of 1. So our legs are 1 and 1. Okay? So we need to plug that in the Pythagorean theorem. And we do that. Okay. Start with our a squared plus b squared equals c squared. Plug in 1 and 1. Square it. Add them. Take the square root. And we get 1.4. Okay. So the distance from this point to this point is 1.4 units. Okay. Now let's try that. Let's see if we can get the same answer using the distance formula. Okay. So what I did, I rewrote the points over here. I labeled them x1 and y1, x2 and y2. Now let's write the formula down. Okay. So copy that formula down. Go ahead and pause the video and see what you can do. Okay, let's check your work here. So here are our points. Let's plug in. Okay, you should have 1.5 minus 2.5. Again, that's 1.5 right here minus 2.5. x2 minus x1. Plus 4.5 minus 3.5. 4.5 here minus 3.5. 4.5 minus 3.5. y2 minus y1. Okay, now all we have to do is follow order of operations. Do what's in parentheses first. Do your subtraction. We get negative 1 in here and a 1 in here. Next, do our squaring. Negative 1 squared is 1. 1 squared is 1. Add them together. We get 2. Square root of 2. 1.4. So you can see, again, we arrive at the same answer. Because they're basically the same, they're the same formula. Okay? Here's just another example that you can take a look at that explains the distance formula. What I want you to do right now, this is the first problem in your guided practice. I want you to try it, do it both ways. And then I'll reveal the answer and you can check to see how you did on your work, okay? So pause the video right now and do guided practice problem number 1 both ways, Pythagorean theorem and the distance formula. Okay, let's check using the Pythagorean theorem. Okay. If you plotted these 2 points, here are your legs, 4 and 2. Square them, add them, take the square root, you should end up with 4.5. So we know when we do the distance formula, we're looking for 4.5. Okay? So let's take a look and see what we have. Here's the formula. I rewrote the points. Always rewrite the points to help you out. Okay? Plug in what you know. Plug in your x2 and your x1s, your y2s and your y1s. Do the subtraction. Do the squaring. Do the adding. And then you should end up with 4.5. So we're okay. So finish the other problems in your guided practice problems and we'll take a look at them tomorrow.